Yeah. Okay, so this session is a session I've held a number of times over the last couple of years. It's called Preparing for IoT, and it's the aim of this session is to help architects who are about to embark on their first IoT projects or are interested in starting working with IoT, and let them know what it is they need to do to prepare, what they need to think about. A little bit about me before we start. I currently have two jobs. I work for Ecru Consulting in Sweden, and I'm also Chief Architect at iDesign, who are based in San Jose. So any of you have done any major work with Windows Communication Foundation will know who those guys are. I'm a former Chief Architect at Microsoft Western Europe. Back in 2014-2015, I was the IoT lead for Microsoft Western Europe. I worked with a lot of the very, very early IoT customers at Microsoft and brought that feedback to the product groups and worked with the product groups on what eventually became IoT Hub, providing a kind of link between the customers and the product groups there for a year. I'm also a CDP certified architect and a trainer for Iasa as well. And currently working on a whole bunch of different IoT projects, from startups to energy companies across Europe. So this presentation isn't the intention to teach you a whole lot of buzzwords or product features. The idea is to give you an overview of what you need to start learning or start thinking about in order to competently work with IoT. And what I want you to take away from the presentation is that there is a real opportunity here as architects to get involved at the cutting edge of what's being called digital transformation. IoT projects tend to be right on the edge of that. One of the most important lessons from this session is that IoT is not static and it's not platformized. So don't fall for the vendors who are trying to tell you that this is an easy thing. You just have to buy my SKU, install my product, and you'll be able to start building these systems. It's not that easy. IoT is a system of systems. It's a little bit more complicated than building a HR system or a billing system. It requires a higher level of architectural skill. Architecture is critical in this. If you don't get the architecture right, these projects tend to end up in the ditch very, very quickly. And one of the most important things that we've learned from working with these projects over the last few years is to really know and understand your business model, to understand why you're doing what you're doing and what the eventual profit will be out of that for your business. So I always start this session off by looking at this guy, Paul Matson, his little joke he made on Twitter. He said, scientists estimate that by 2018 the number of Internet of Things infographics will exceed the number of connected devices, which is funny, a little bit sarcastic, but it kind of hints at the growing skepticism that's out there around IoT. There's way too many vendors, way too many consultants hyping this up and trying to get on the bandwagon. And what you'll generally see, and I think the industry is very sick of this by now, is IoT presentations that look like this. So they'll start off by talking about the numbers. They'll say we have billions of devices, trillions of transactions, and gazillions of dollars, and these numbers have been shown to be incredibly exaggerated already. They'll go on to talk about something, some novelty like a talking fridge or something like that. They'll present the reason why they're the expert, why you should listen to them, why you should give them your money, why you should buy their product. Then to make it seem serious, they'll throw in a scary piece about Skynet or Minority Report or something like that, on how your fridge is going to kill you. And then they'll finish up by talking about the huge financial opportunity that there is in this. And I think it's time as an industry that we move beyond this kind of hyped up presentation. and started thinking about how to actually get value out of these things. This is the Gartner hype cycle from a few years ago, showing Internet of Things rapidly approaching the peak of inflated expectations. And I think we're definitely at the top of that peak now. What we can expect to come after this in Gartner's model is the trough of disillusionment, where we're going to have a lot of field projects. We're starting to see reports coming out in the media, in the IT press, saying that the size of the IoT market has been massively overestimated by factors of 10 and 50. And we're starting to see frustration. A lot of companies are stalling at 100 connected devices. The business models aren't quite working out, and there is a litany of field IoT endeavors, because there's a lot more complexity to this than what people think. And eventually then we'll head on to the slope of enlightenment, where we start to see real value being delivered in some customers, and those ideas and case studies will be picked up by others, and eventually we'll reach this plateau of productivity. And this journey, when we look at this, and then we expected this within IoT for a long time, it makes me think back 10 years ago to maybe 12 years ago when we were doing SOA for the first time. And it had exactly this journey, and as it went into the trough of disillusionment, despite the fact that that's marked by a lot of field projects and missed expectations, there were still projects in that trough of disillusionment during that period of time that actually succeeded, and if there wasn't, then there would never be any slope of enlightenment. The difference between the projects that were succeeding during that time and the projects that weren't succeeding was architecture. And as we approach this trough of disillusionment with IoT, the only way to actually succeed is to pay attention to the architecture and to make sure that we're building the right thing and that we're building it right. And so with that kind of cynical and skeptical introduction, you might ask yourself, well, why should I work with IoT at all as an architect? There's a couple of really compelling reasons for me anyway. The first one is business impact. So a lot of these projects are right on the cutting edge of new business models being defined by companies, especially if you've been working with industrial IoT. These projects have a real business impact with real business cases, and they give you a chance to work with those things and to sharpen your skills on that level. The second thing is that for me, this is IoT is cloud. It has to be done in the cloud. There isn't really any other way to handle the scale of doing this. And it gives you a chance to work with the latest and greatest of cloud technologies and cut your teeth there. And the third thing, for anyone who is in any way interested in the development of software architecture, the things that are being done in IoT in terms of scale, in terms of security, in terms of analytics, are going to have a dramatic effect on the future of software architecture. And so if you're in any way interested in the development of software architecture, in the growth of new ideas and patterns, then this is the place to be. So I'll start by talking a little bit about the early projects that I was involved in and some of the traps that people tend to get caught in. The experience that we've had with the IoT projects is that they generally involved a more advanced form of architecture than a lot of architects are used to working with. So there are huge elements of scale, and there's a lot of complexity, there's a lot of moving parts, there's a lot of things that have never been done before that you maybe have to jump in and try and do. There are a lot of complexities around different kinds of devices and different protocols and things that you have to learn. And what we see in a lot of projects is that they tend to start off small. It tends to be someone's idea in R&D, or someone in the IT department thinks, hey, we could connect up these devices. So they start off by getting one device and connecting it up to a server, and generally using standard enterprise developer tools. So it tends to be things like web APIs and HTTP connections. And it starts off small, and then they add another device and another device, and then somebody tries to sell it to a customer and they're successful. It starts to grow a little bit. As it grows, the system gets patched in an ad hoc nature, and we start to try and scale up the system by adding a little bit more hardware. The volumes of data start to grow, and before you know it, you're mired in a solution that you can't cut off because customers are paying for it. You can't shut it down, but it's costing you an insane amount of money to maintain. And the very first IoT projects that we worked on at Microsoft tended to have this pattern, and then they came to Microsoft for help and said, hey, we have this system, it's huge, it's impossible to manage, it's become incredibly expensive to change, we can't cope with the amount of devices, and you have this cloud thing, so maybe you can help us. And that tends to be a very standard anti-pattern that we see in IoT projects. So that we start off and we build them in this ad hoc nature rather than having a plan from the start. The thing that makes IoT projects different are the requirements. So we have many devices. We have a huge scale. We have very vague security requirements, and even vaguer security solutions, we could say. Large volumes of data, and a whole lot of integration, very often integration to back-end systems that have never been built to cope with the kind of volume of data that flows from all of these devices. And as we start to try and meet these requirements, these are the four kind of information exchange patterns within IoT that get all the attention. And this is what the developers tend to focus on. And these things are very important, but they aren't the be-all and end-all of IoT. This is basic functionality, but if you don't pay attention to all the things that are going on around this, you can very quickly end up in trouble. So you can see that telemetry is when we have devices flowing their information, telling something about themselves. Perhaps it's a temperature sensor telling you what temperature it is, something like that. Then we have inquiries, where devices ask your back-end system for some information about the world beyond their scope. Commands are a very important part of IoT, where we can actually tell the device to do something. And notifications also, when we tell the device something about the world beyond its scope. One of the more worrying anti-patterns that I'm seeing at the minute in IoT projects is that we look at the first pattern here, telemetry. There's a kind of a myth going on at the minute that IoT is all about analytics, and people tend to think that the only thing they have to do is gather data and do some whiz-bang machine learning on that data, and that's an IoT project. And when you follow that kind of pattern, what tends to happen is the focus is on pulling in data and doing analytics. Eventually the use case will change, and you'll have to send information flowing back the other way to the devices. But if you've been focused on it being an analytics only play, then that can be a very expensive change to make. So that's something to watch out for. So those are the four basic patterns. And if you're a software architect who's been around for a while and you've built some of let's say SOA-based, service-based systems, you'll think, why is this so difficult? Why can't we just solve this in the way that we always did? For example, we have the concept of endpoints is very clear from service orientation. Obviously, some kind of message passing to get messages from devices to the back-end system and vice versa. Transport and message security were already established many years ago with the WS star protocols. Some kind of publish subscribe mechanism. We already had systems like BizTalk, systems like WebSphere, TIBCO, service bus in Windows Azure, and command routing, which is hardly new. to us. And so it's very, very tempting to approach these IoT projects with these old patterns, with these old technologies. So a bunch of services connected to databases. And that's what a lot of the early IoT projects look like. And as I mentioned, they tend to fall down very, very quickly. The reason that you start to get problems if you follow this approach using the old kind of N-tier solution architectures, firstly, it's addressing. How do you address tens of millions of devices? How do you give them an address? How do you know where they are? There's a couple of problems with that. One is that if you want to, for example, give them IP addresses, you have to set up some kind of VPN, some kind of DHCP system, and that creates a lot of overhead, a lot of cost, and a lot of complexity in your environment. The other thing is that if you give your devices an address, you're immediately creating an absolutely massive attack surface, which we don't really want to do. Another thing is the scale. If you have millions of devices all sending a message every second, these old style SOA endpoints based either Java or .NET based really can't cope with that kind of scale in any easy way. You have connectivity issues. So a lot of these devices, they may not be connected all the time. They may have intermittent connections. They may actually be moving in the case of cars, trucks, lorries and things like that. And in a lot of cases, the devices might be so small that they can't support a HTTP, let alone a TLS stack. Another challenge is the sheer volume of data, and we've seen customers who built their original systems on SQL Server, for example, see those databases completely overwhelmed as the number of devices and the amount of data that came from those devices started to grow. And also the device size can be a real challenge as well. Like I mentioned, it may not be big enough to support a TLS or HTTP stack. And so if we try and solve these problems from first principles, then how would we actually do this? Well, one way we solve the addressing problem is that we simply don't do addressing. We allow our devices to exist on the internet and to receive their messages from queues, so that we use a pattern called solicited push, where the device actually listens on a queue and we push messages to the queue, which we know where the queue is, rather than to the device. That solves the problem of how do we address all these devices, and it also reduces the attack surface of our solution massively. We solve the problem of scale by using cloud. Again, queues and pub sub allow us to solve the problem of intermittent connectivity. The data we can solve again with cloud storage, things like HD Insight. Allows us to work with much larger volumes of data than we did on-premise. And the device size has been solved by using smaller, more lightweight protocols, AMQP being my favorite, MQTT being everybody else's, and also the use of gateway patterns where smaller devices can connect to a more able device in close proximity to them, perhaps. That aggregates and works and creates the connection to the cloud-based backend. When we put all of these ideas together, we solve this from first principles like the good architects we are. When we put all these things together, we get a bunch of patterns which, with much credit to Clemens Vasters for his work in this area, this is almost entirely his doing. We have a bunch of patterns which we call service-assisted communication, and service-assisted communication basically presents us with a solution that looks like this. We have a cloud gateway that separates our back-end components, so the components responsible for storing data, processing data, sending messages back to our devices. And they speak to the devices through a command API. inside our cloud gateway, we have the concept of an inbox and an outbox, which is essentially an abstraction of queuing. And we have some kind of protocol head in our cloud gateway that allows the cloud system to translate between the language or the protocol that the devices speak and the protocol, the language or protocol that's necessary to speak with the back-end components. So very often on the back end we'll see HTTP and REST for that command API. The protocol head can also be HTTP, can be MQTT or AMQP or any custom protocol that you feel like implementing yourself in the cloud. So the journey that we went through as we were doing this across the period of a couple of years was we started off solving all these problems with service bus and worker rules for the simple reason that that was all we had. And we started to realize that there's a great deal of repetitive work in this, and there must be an easier way to do this, was our thinking at the time. The first effort to do that was a project called Reykjavik, which I'm sure everyone's forgotten by now. That was superseded by a more commercial attempt, which we call the Intelligent Systems Service, which was a first attempt at doing a software as a service approach to IoT. That showed itself to be very limited, given that IoT projects were so variable. There were so many things that were volatile in an IoT project that it was very, very difficult to nail it down to a single SaaS solution with a GUI. The evolution of Service Bus then, as they realized the limitations in dealing with this amount of connections and this amount of devices, led to Event Hub, and Event Hub fed into the stream that eventually produced something called IoT Hub, which is basically a large-scale implementation of the service-assisted communication pattern. IoT Hub is something that, while it won't solve every single one of your IoT problems out of the box, it will save you an incredible amount of time in developing an IoT solution. It takes care of a few really difficult to implement things. One is the ability to have millions and millions of devices connected at the same time. The other thing is authentication. How do you manage device authentication, and how do you create credentials for them? It gives you inbuilt support for the most commonly used protocols, and it's also designed to be extensible. And it gives you SDKs for multiple platforms, depending what your devices are running. So that there are client SDKs that make it easier for you to write C libraries for Linux systems, for example. So IoT Hub will save you a lot of time, and it's a component that's really worth looking into. Aside from the IoT Hub, you're going to need a whole lot of other pieces to make this work properly. So in this diagram, which is the Azure IoT reference architecture, which was also the result of the work we did over a number of years at Microsoft, you can see that the IoT Hub takes the place of what we call a cloud gateway here. There's a whole bunch of other stuff we have to do. We have to have some way of moving data into storage. We have to have some way of performing a business logic over streaming data, some way of integrating to our back-end business system, some way of presenting information to consumers of that data, perhaps on mobile devices. And the IoT reference architecture is something, if you're interested in digging into this, is something that you absolutely have to read through. It's about 70 or 80 pages. It's fairly tough going. But if you can make it through that, a couple of passes through that document, then you'll be well prepared to start working with IoT on the Azure platform. One thing that you're going to see a lot of is something called the Azure IoT Suite, which is an attempt to make it easier to do things like launch pre-configured solutions, which will take a large number of Azure components and connect them together for you, doing all that glue in between in order to build a pre-configured solution. This is a fantastic thing to do for proof of concept, but generally when you're building a real-world project, don't assume that something like IoT Suite is going to be able to deliver everything that's needed in an IoT project. And so you will have to do a lot of custom work, and sometimes it's easier to just start from the beginning yourself. So what does an IoT project actually involve? What are you going to find yourself doing in an IoT project? So the first thing you'll do is obviously you will probably implement these 4 information exchange patterns between your devices and your back-end systems. But don't get too focused on those, because there's a whole lot of really important work that you need to do in order to make sure your project actually succeeds. So just because you've established communication with a few devices in a proof of concept doesn't mean that you're home and dry. The first thing is provisioning. And this is a really important use case in your IoT scenarios. How do you provision a device? How does a device know where to call your backend? Do you do that in the factory? Do you do that when the device starts up? How do you load the device with keys? How do you handle a device that is perhaps bought by one person and sold secondhand to another person? How do you re-provision that device if the security key or the mechanism has timed out in some way? And the other thing you have to work with is security as well. How do you secure a device? How do you secure the back end of your system? How do you ensure that users who are coming in from the back end can only access information and commands for devices that they are supposed to have access to? These are things that you need to spend some time on up front, because you can paint yourself into a corner very, very easily. One of the most common failures in IoT projects is simply not being able to cope with the scale. And unbelievably, a huge number of IoT projects are run without doing any regimented or structured scaling or load testing. The idea of scale units is incredibly important in this, that you establish your scale unit. You know how many devices a single IoT hub or protocol gateway can support. You know how many devices your back-end systems can cope with before you have to buffer them or scale them up or scale them out. You will have to do a lot of integration work between your IoT solution, and very commonly we see that there's some need to integrate this with a CRM system, such as Dynamics or Salesforce, or something proprietary that you have on-premise. And another piece that's very, very common that you have to spend a lot of time and a lot of money on is resiliency, making sure that there's a sufficient level of quality in the solution, that you're able to manage outages, and that you don't end up with frustrated or disappointed customers. And in a lot of cases, if we don't pay attention to that, we actually see that when back-end IoT platforms go down, it's not uncommon that devices get bricked, that they cease working while the back-end is down, something that's incredibly frustrating for end customers of those devices. So there are a lot of risks in these IoT projects, and what I usually do when I'm mentoring or coaching architects who are beginning to work with this, I say that old ways of thinking are quite dangerous. So if you come from the world of N-tier application design, where you're used to having a front end and some services and a database behind that, IoT can be a bit of a shock to the system. It's many times more complex than building the business systems of old. Make sure that you understand the business model behind the IoT project before you even start, because a lot of the decisions you'll make around the architecture will be driven by the business model, and in many cases, from a technical perspective, we tend to find out too late that we've designed or built a system that's too expensive. Many times when you're working with device manufacturers, especially, for example, in the area of white goods, you'll find that the margins aren't incredibly high, and you have to work very hard to make sure that you're not spending too much there as well. And one of the most common anti-patterns that I see in IoT is also this idea of build it and they will come. So people tend to spend a lot of money building a very nice IoT platform, but the business isn't directly on board, and there isn't actually a business model for doing any of this kind of thing. A lack of systems thinking. So one of the big problems with IoT projects is that they are systems of systems. When things go wrong in these systems, it's very, very easy for there to be contagion and for crashes and faults to spread right out through the system, which can be an absolute nightmare from an operations perspective. So it's important to put the work in terms of doing things like your failure mode analysis to make sure that you understand how the system works, how the system reacts to failure, and how you'll cope with that on an operational level. For some customers, this is a piece of advice that's very important, but don't focus on the device. It is important to have, obviously, to have code running on the device that works and allows you to communicate with the cloud, but it is very, very common that a large amount of time is spent trying to optimize the device, and then there's a much smaller amount of time and budget left to focus on the back-end system where the real benefits are. And finally, don't obsess on choices. It's really important to just get something done. What we see in this market around IoT projects is that established companies can very easily find themselves outplayed and outsmarted by much smaller competitors. And what I've seen across the industries is that startups tend to move much faster, and big companies tend to have meeting after meeting trying to decide on exactly the perfect protocol, so that they can save 1 cent per device on the bandwidth that's consumed by that device. It really is time to market is a big issue for these IoT projects. Other things, so for example, protocol indecision, I would say, is a very common hallmark of failing IoT projects. Just endless debates about protocols. It's much better to get something up and running and change the protocol afterwards than to write a thesis on why MQTT is slightly better, has a slightly smaller footprint than AMQP. VPNs are something that we've seen used in a lot of IoT solutions. This comes from old school data center thinking. Telecoms providers like to sell you APNs, which is kind of like a mobile private network. These things aren't entirely necessary, and before you go that way, make sure that there is a real business requirement driving that, because the ideas around service-assisted communication mean that you generally don't actually need this kind of solution. Another anti-pattern that we see in IoT projects that we need to be aware of is the idea of migration versus rebuild. So for a lot of customers who build these ad hoc on-premise end-tier based systems, there is a belief that simply migrating this to the cloud will solve all their problems because there's a lot of magic scalability in the cloud, which generally doesn't happen. So if you have a system that's performing poorly on-premise, it'll probably also perform poorly on the cloud. So be prepared to re-architect those solutions rather than simply move them. Something that can really catch you out is international concerns. So for a lot of large companies, it's about rolling out in more than one country. Data privacy laws in Germany, in Russia, and China can make this really, really difficult. So don't build your system in the United States or in Western Europe and assume that the same system will be applicable in every single country that you roll out to. Business model alignment, as I've already said, make sure that you understand the business model, make sure that you're aligned to the business model, and this is a really good way to get out of analysis paralysis, because it answers your questions very, very quickly about which protocol you can use, or whether the protocol discussion is even necessary. And again, I'm referencing the build it and they will come anti-pattern, which really is dangerous for IT departments, and we're going to see a lot of unused IoT platforms over the next couple of years. Other things to avoid is to watch out for embedded developers who've decided that they're going to build a back-end system. Usually doesn't go well. Watch out for back-end developers who've decided to bring their hobby to work and build embedded systems and start messing around on the devices. Try to keep people into their specialities. No one person's going to be able to do it all. And again, watch out for that lack of systems thinking. Another thing that catches beginners to IoT by surprise is the idea of disintermediation. So IoT at the minute is all about everyone trying to eat everyone else's lunch. So you're going to have a supply chain, and all along that supply chain, from the makers of sensors to the people who assemble those sensors inside a device that they're manufacturing, to the people who write the software that controls that device, to the people who sell you the license for that, will believe that the data belongs to them and the right to earn money from the IoT use cases belongs to them. Be very, very careful what you sign. Be very, very careful to make sure that if you buy an IoT solution from a vendor, that you have access to the data that you need to have access, and not simply to some data dump that they're going to provide you. And be prepared for strange behavior along the supply chains. So now that we've talked about the kind of patterns that are involved in this, and the kind of risks that are involved in these projects, the first question from architects is, what technologies do I need to know in order to do this? And this is very much focused on the Microsoft stack, but you know, these things are mirrored on AWS. It's not particularly different. One of the things I did at Microsoft was to prepare our architects to go out into the world and deliver these kinds of projects, was that I put together a couple of 5-day courses in order to prepare them to talk to customers and to be able to work in these things. And these courses tended to be really, really intense, 10-hour days, where we talked about things like we would go through the basic IoT architecture, the kind of thing that we've skimmed over in this session. We would go through specific technologies like Event Hub, IoT Hub. We also had to look at things like the digital experience, Power BI, streaming analytics, and machine learning. And so in the course of 1 week, you would be covering a whole lot of ground. And you can see on the screen the kind of depth that you could get into. We see here cost functions from linear regressions that we were learning about for machine learning. This is an AMQP frame described. And down here we have some tumbling windows in stream analytics. So this is an incredibly broad topic, and IoT can mean different things to different people, and it can touch any of these areas. There is no one person who can possibly learn all of these things. So if you're looking to start to work as an architect in IoT projects, be prepared to know what you don't know and to use expert help when you need it. Systems thinking, again, scalability, availability, resiliency, and maintainability of these systems aren't things that we can allow to happen by accident. We have to use scale units, we have to plan for availability, we have to make sure that we use techniques like failure mode effects analysis to make sure that our systems are resilient and maintainable. If we don't pay attention to these things, if we focus simply on the functionality of delivering messages from devices to backend, then we will generally fail. And this is where a lot of projects tend to fall down. Two techniques that I recommend to everyone starting to work with IoT projects are the failure mode effects analysis and the architecture trade-off analysis method. This is an Iasa call, so this shouldn't be strange to people. These are obviously applicable in every project. The complexities and the difficulties of IoT means that these things are even more important than they normally would be. As a software architect, I started to realize my own limitations when I was working with these things, so I embarked on this course from MIT, Architecture and Systems Engineering, which is about the architecture from the perspective of the aeronautical industry, what I usually call real engineers. And this has helped me it's given me a lot of tools, a lot of models and methods to help manage the complexity of these things and to understand the way that the engineers who are actually building the devices think. And this has been a great way to bridge that gap from my work experience of the world through software, moving into operational technology, which most of us don't really know very well. So some kind, or maybe not this course in particular, but some kind of, you'll need to make some kind of effort to bridge that gap if you're coming from a software background. And so to summarize, if you want to get involved with IoT, first learn about service-assisted communication, learn about the basic patterns that underpin not only the IoT on the Azure stack, but it's the same basic patterns in any IoT platform. Understand the thinking behind the Azure IoT reference architecture. If you want to play around, use the Azure IoT suite. It's a fast way to learn the platform. Know what you don't know, and be very aware that this isn't simple enterprise IoT IT applications. This is a system of systems, and learn systems engineering techniques in order to be able to manage that.